As our students, in the last class, you have discussed about matrices and the order of the matrices, right? Now, in this video, we are going to discuss about types of matrices. The matrices are classified into 7 types. They are column matrix, row matrix, square matrix, diagonal matrix, scalar matrix, identity matrix, and finally zero matrix. So now let us discuss one by one. So first one is column matrix. So now very first one is column matrix. Column matrix means a matrix having only one column and any number of rows. Rows may be any numbers, right? Now example, it is given by, for example, matrix A is a column matrix and it has only one column elements and any number of rows. These are all rows. Here first row, second row and third row, and only one number of column. That is called column matrix. Order of this matrix is, order means, as you know all, order means number of rows by number of columns. Here there are 3 rows are there and only one column is there. Hence its order becomes 3 by 1. In generally, order of the column matrix is denoted by like this, m by 1. M indicates number of rows and 1 indicates number of columns. Similarly, so where the next one is row matrix. So definition of row matrix is a matrix having only one row and any number of columns. That is called row matrix. For example, like this, here only one row is there and a number of columns are there. See, this is first column, second column, and this one is third column, and there is only one row. Like these matrices are very best examples for row matrix. Now, in general, order of the row matrix is given by 1 by n. Here 1 indicates number of rows, n indicates number of columns. There is only one row is there and n number of columns. Therefore, order of the row matrix is 1 by n. So the next one is square matrix. The square matrix means, definition of square matrix is, it is a matrix.
Start first in the.
Next one is square matrix. So square matrix means it is a matrix in which number of rows is same and is equal to number of columns. Let us take an example. Here matrix E is a square matrix. These are all, as you know, rows and these vertical elements are columns. Here there are 2 columns, there are 2 rows. Therefore, like this matrix are referred as square matrix. And generally, the order of the square matrix is given by m by n. Here, m indicates number of rows, m indicates number of columns. Here, rows and columns are equal to each other. Therefore, order becomes m by n. Or simply, it is also denoted by like this, order m. Order. This is called square matrix. Now, let us move towards diagonal matrix. So, diagonal matrix means it is a square matrix. First thing, one thing is diagonal matrix is a square matrix in which all the elements are 0 except principal diagonal elements. So let me explain. Principal diagonal elements means these elements are called principal diagonal elements. So diagonal matrix is a square matrix in which all the elements are equal to 0 except these main diagonal elements, for all principal diagonal elements. So in general, the order of the diagonal matrix is given by m by n. Here m indicates rows, m indicates columns. It is same as square matrix. So now let's move towards another matrix, identity matrix. So next one is scalar matrix. So it is a diagonal matrix. As you know, all diagonal matrix means it is a square matrix in which all the elements are equal to 0 except principal diagonal elements. See, scalar matrix means it is a diagonal matrix in which all the principal diagonal elements are equal to each other. For example, take down E is a matrix first row elements 2 0 0, second row elements 0 2 0, and last row element, third row elements 0 0 2. See, as you know, all these elements are called principal diagonal elements. These entries are equal to each other in a scalar matrix. Like this matrix are termed as scalar matrix. Now come to the next one. Next one is in general. The order of the diagonal matrix is given by m by m. M indicates rows, m indicates columns. So simply it can be termed as M matrix. Now identity matrix. Identity matrix means it is a square matrix. Square matrix means, as you know, number of rows and number of columns are equal to each other. Here identity matrix is a square matrix in which all the elements are 0 and principal diagonal elements are equal to 1. So now principal diagonal elements means these elements. These elements are always equal to 1 in identity matrix and rest of the elements are equal to 0. Take one more example. First row elements 1 0 0, second row elements 0 1 0, third row elements 0 0. These elements are termed as principal diagonal elements. In an identity matrix, principal diagonal elements always equal to 1 and rest of the elements are 0. So in general, order of the identity matrix is termed as M by M. So simply order M1, right? Now very next one is zero matrix. Zero matrix means it is a matrix in which all the elements are 0. It is given by, usually zero matrix is denoted by the letter row and given by like all the entries are equal to 0. In general, the order of the zero matrix is given by M by N. It may be any rows and any number of columns. M indicates rows, N indicates number of columns. Here we took 2 rows and 2 columns. It's order 2 by 2, and this one is 2 rows and 3 columns. Order is 2 by 3, like this. This is all classification of matrices. Now let's move towards another concept, that is operations on matrices. Operations means all addition, subtraction and multiplication of matrices. Now take the operations on matrices. So next one is scalar matrix. So it is a diagonal matrix. As you know, all diagonal matrix means it is a square matrix in which all the elements are equal to 0 except principal diagonal elements. See, scalar matrix means it is a diagonal matrix in which all the principal diagonal elements are equal to each other. For example, take down E is a matrix. First row elements 2 0 0, second row elements 0 2 0, and last row element, third row elements 0 0 2. See, as you know, all these elements are called principal diagonal elements. These entries are equal to each other in a scalar matrix. Like this matrix are termed as scalar matrix. Now come to the next one. Next one is in general. The order of the diagonal matrix is given by M by M. M indicates rows, M indicates columns. So simply it can be termed as M matrix. Now identity matrix. Identity matrix means it is a square matrix. Square matrix means, as you know, number of rows and number of columns are equal to each other. Here identity matrix is a square matrix in which all the elements are 0 and principal diagonal elements are equal to 1. So now principal diagonal elements means these elements. These elements are always equal to 1 in identity matrix and rest of the elements are equal to 0. Take one more example. First row elements 1 0 0, second row elements 0 1 0, third row elements 0 0. These elements are termed as principal diagonal elements. In an identity matrix, principal diagonal elements always equal to 1 and rest of the elements are 0. So in general, order of the identity matrix is termed as M by M. So simply order M1, right? Now very next one is zero matrix. Zero matrix means it is a matrix in which all the elements are 0. It is given by, usually zero matrix is denoted by the letter row and given by like all the entries are equal to 0. In general, the order of the zero matrix is given by m by n. It may be any rows and any number of columns. M indicates rows, n indicates number of columns. Here we took 2 rows and 2 columns. Its order is 2 by 2, and this one is 2 rows and 3 columns. Order is 2 by 3, like this. This is all classification of matrices. Now let's move towards another concept, that is operations on matrices. Operations means all addition, subtraction and multiplication of matrices. Now take the operations on matrices. So now operations on matrices. Very first one is addition of matrices. So let us consider any two matrices. Here I take A and B or any two matrices. A is equal to A is having order m by n, and matrix B is equal to elements B I is having order m by n. B, any two matrices, then their addition is defined only when the number of rows of the matrix A must be same and is equal to number of rows of the matrix B, and similarly the number of columns of the matrix A is same and is equal to number of columns of the matrix B. Then the corresponding elements are added. So let's take an example. Example is, here A is a matrix having order 2 by 2. There are 2 rows, 2 columns with the elements. First row elements 3, 5, second row elements 7, 9. And matrix B also 2 by 2 matrix. First row elements 1, 2, second row elements 3, 4. Then their sum, that is, then their addition is given by corresponding elements, means first row first element of matrix A added to first row first element of matrix B, that is 3 plus 1. In the same manner, first row second elements of matrix A added to first row second element of matrix B, that is 5 plus 2. In the same manner, second row elements of matrix A and matrix B is given by 7 plus 3 and 9 plus 4, and resultant matrix, that is equal to 4 first row elements 4, 7, second row elements 10. This is all about addition of two matrices. So keep in your mind that addition of the matrices is defined only when order of the matrices are equal to each other. Okay. Next is subtraction of matrices. Okay. Is subtraction of matrices. So let us consider here also any two matrices. Here A and B are two matrices. Here A is a matrix having elements A is A and order is m by n, and B is a matrix having elements B is A and its order is m by n. B, any two matrices, then their subtraction is defined only when the number of rows of matrix A is same and is equal to number of rows of matrix B, and the number of columns of matrix A is same and is equal to number of columns of the matrix B. Then the corresponding elements are subtracted. So let us take an example. Here A and B are any two matrices. Here A is elements. First row element 7, 9, second row element 10, 3. See, order of the matrix means 2 by 2. There are 2 rows and 2 columns. Let us consider another matrix B, and first row elements 3, 2, second row elements 1, 0. Here also order becomes 2 by 2. 2 rows are there and 2 columns are there. Now then the subtraction is given by A minus B, that is equal corresponding elements are subtracted from the matrix A to the matrix B. Then the subtraction is corresponding first row first element of matrix A subtracted B. First row first element of matrix B, that is 7 minus 3. Similarly, first row second element of matrix B subtracted B. First row second element of matrix B, that is 9 minus 2. Like the second row elements. Then resultant matrix, that is equal to 4, 7 and 9, 3. This is all about subtraction of matrices. Next is multiplication of matrices. So next is multiplication of matrices. So multiplication of matrices, let us consider any two matrices. Here also A and B are any two matrices. Consider A is equal to Aij elements Aij having order m by n, and matrix B is equal to elements Bij having order P by Q. Be any two matrices, then their product, then their multiplication is defined only when these two matrices satisfy some conditions. Conditions are number of columns of the matrix A. Here matrix A means this is first matrix, pre-multiplier matrix. This matrix is called as pre-multiplier, and matrix B is post-multiplier. Number of columns of pre-multiplier matrix is same and is equal to number of rows of post-multiplier matrix B. Have you understood this? That means, see, this n means n indicates number of columns of matrix A. That must be equal to number of rows of matrix B. If two matrices satisfy these conditions, means then only multiplication of matrices is defined, otherwise not. Keep in your mind that number of columns of matrix A is equal to number of columns of matrix B. Then the desired matrix or resultant matrix or required matrix will be having the order number of rows of matrix A by number of columns of matrix B. So if you are not understood this till, let's take an example. Here A is a matrix having first row elements 1, 2, 3. Order of this matrix is 1 by 3 because only one row and 3 columns are there. Then its order is 1 by 3. And another matrix B, here only one column is there and 3 rows are there. Order of the matrix becomes 3 by 1. Then their product, then their multiplication is given by AB is equal to, see, first row first elements. See here, number of columns of matrix A is equal to number of rows of matrix B. Therefore, product of the matrix is defined. Now product is as follows. So first row first element of matrix A is multiplied with first row first column of matrix B, it is 1 into 4, and first row second element of matrix A is multiplied with first column second element of matrix B, that is 2 into 5, that becomes 10. First row third element of matrix A is multiplied with first column third element of matrix B, that is 3 into 6, that becomes 18. So now the sum of all these elements gives 32. This is called desired matrix. As you know, what desired matrix having the order number of rows of matrix A by number of columns of matrix B. That is 1 by 1. That is called desired matrix, resultant matrix, required matrix having order 1 by 1. This is all about multiplication of two matrices. Multiplication of two matrices is defined only when number of columns of matrix A is equal to number of rows of matrix B. First you have to check this condition, then let's move towards multiplication of the matrices. Multiplication of the, we have to take first row, first column, first row, second column, like that. Okay, later on we will take some more examples. So let's take one more example. Here is a matrix A. So matrix A having the elements, first row elements 1, 2, second row elements 3, 4, and its order becomes 2 by 2 because 2 number of rows and 2 number of columns are there. Similarly, let us take one more matrix B. Matrix B having the elements, first row elements 5, 7, second row elements 2, 6, and its order becomes 2 by 2 because 2 rows are there and 2 columns are there. Now we are going to find product of the matrices AB. As you know, here the matrix A is called pre-multiplier matrix and matrix B is called post-multiplier matrix, right? So now the multiplication rule is number of columns of the matrix A. Number of columns means this one. There are 2 number of columns are there in matrix A. That must be equal to number of rows in matrix B. See, in matrix B, there are 2 number of rows are there. These are 2 number of rows. See, if a number of columns of matrix A is equal to number of rows of matrix B, then a product of the matrix is defined. it as follows. So product of the matrices is given by, so first row, first elements. We have to multiply first row element of matrix A by first column element of matrix B, like this. So 1 into 5 plus first row second element of matrix A is multiplied with first column second element of matrix B, that is 2 into 2. Similarly, first row element of matrix A is multiplied with second column element of matrix B, that is 1 into 7 plus, again, first row second element of matrix A is multiplied with second column second element of matrix B, that is 2 into 6. Clear? Now, second row is multiplied with first column of matrix B. So, second row element of matrix A is 3, 4. First column element of matrix B is 5, 2. So, second row first element 3. First column first element of matrix B is 5. 3 into 5, that gives 15. Again, second row second element of matrix B, matrix A is 4, is multiplied with first column second element of matrix B, that is 2, and multiplication of 4 and 2 gives 8. Similarly, second row elements of matrix A is multiplied with second column element of matrix B, that is 3 is multiplied with 7 gives 21, and 4 multiplied with 6, that gives 24. So now sum of these elements gives 5, 4, 9, and 7, 12, sum becomes 19, 15, 8, that becomes 23, and 21, 24, that becomes 45. This is all about multiplication of the matrices. See, as you know, desired matrix, resultant matrix will be having the order number of rows of matrix A by number of columns of matrix B. Here 2 number of rows is there, 2 number of columns. Then the desired matrix having the order 2 by 2. This is all about multiplication of matrices.
Go.
Next concept is equality of matrices. Students, let us consider any two matrices here also. A and B are any two matrices. Here the matrix A having the elements A is A with order M by N, and matrix B having the element B is A with order P by Q. Be any two matrices are said to be equal. If and only if they must satisfy certain conditions. They are number of rows of matrix A is same and is equal to number of rows of matrix B, and number of columns of matrix A is same and is equal to number of columns of matrix B. Each element of A is same and is equal to each element of matrix B. That is simply noted as Aij is equal to Bij. Here Aij indicates elements of matrix A, Bij indicates elements of matrix B. So for all I and J, I indicates rows, J indicate columns, right? Okay, so let us take an example. So here matrix A having elements 1, 2, 3, 4 and matrix B having elements 1, 2, 3, 4. So here both the matrix having same order. So equality of the matrices means matrices they must be having same order. Yeah, matrix A that is 2 by 2 matrix. Matrix B also 2 by 2. So each corresponding element of matrix A is same and is equal to corresponding element of matrix B. See, like this. The first row, second element of matrix A is same and is equal to first row, second element of matrix B. Second row, first element of matrix A is same and is equal to second row, first element of matrix B. Second row, second element of matrix A is same and is equal to second row, second element of matrix B. This is all about equality of matrices. Equality of matrices means they must have same order. Okay, and each element of A is same and is equal to each element of matrix B. So, okay, let us take some examples of construction of matrices.
Go.
So now in this video we are going to discuss some examples on the construction of matrices. So first example is construct a 2 by 2 matrix. Matrix A is equal to Aij, whose elements are given by Aij is equal to I plus j whole square by 2. So we have to construct, we have to find 2 by 2 matrix. So first we have to consider general matrix of order 2. So first we have 2 by 2 matrix is given by general matrix of 2 by 2 order is given by A11, A12, A21, A2. This is the general matrix with order 2 by 2. 2 rows and 2. Here the elements of the matrix is defined. Aij is equal to I plus j whole square by 2 upon 2. Here is elements of the matrix is defined as I plus j whole square upon 2. See, I indicates this one. This element is I and next element is j. So first row, first element. That is first row, first column. A11 indicates I is j. I is like this. Here I means 1, j means 2. I means 2, j means 1. I means 2, j means 2. So now elements of the matrix. A1, first row, first element is given by I plus j whole square means 1 plus 1 whole square is 2 square. 2 square is 4 divided by 2. 4 by 2 becomes 2. So next element means A12. A12. Yeah, I plus j whole square. Elements of the matrix I plus j whole square upon 2. I plus j means 1 plus 2. 1 plus 2, 3. Square means 9 by 2. So next row elements A21. I plus j 2 plus 1 whole square means 9. 3 square divided by 2. Next is last element A22. A22 means I plus j 2 plus 2 whole square, that is 16 divided by 2. 16 by 2. So now resultant matrix. The required matrix is given by A is equal to, therefore desired matrix becomes A is equal to A11 element is 2, A12 element is 9 by 2 and A21 element is 9 by 2 and A22 element is, this is called required matrix. Similarly, one more example is there. So elements of the matrix AI. The second example is, elements of the matrices is given by, first we have to consider that elements of the matrix Aij is defined as 1 by 2 modulus of minus 3i plus j. Minus 3i plus z. So here also we have to consider general matrix of order 2 by 2 matrix we have to consider. So matrix, general matrix A is equal to, let us consider 2 by 2 matrix. 2 by 2 matrix, first row elements is A11, A12. Second row elements A21, A22. See here, as you know, all A11 indicate first row first elements, A12 indicate first row second elements, A21 indicates second row first elements, A22 indicates second row second elements. Now, elements of the matrix is defined as Aij is equal to 1 by 2 into modulus of minus 3i plus j. Now, first row first elements, here it becomes A11 elements becomes 1 by 2 into modulus of minus 3i plus j, minus 3 into 1, I means 1 plus j into 1, that is 1. It is equal to 1 by 2 minus 3 plus 1, that becomes minus 2. See here, modulus sign is there, symbol of modulus indicates, modulus means that is distance, distance is never negative. So we have to consider it as positive quantity, 2 by 2, that becomes 1. Next, similarly, consider first row second element A12. So elements of the matrix is defined as 1 by 2 minus 3i plus j. So minus 3 into 1, that gives minus 3 plus z. Z means here 2. 1 by 2 into minus 3 plus 2, that gives minus 1 is equal to, here also modulus means that is distance, distance is never negative, you have to take positive quantity, 1 by 2, that becomes 1 by 2. So now second row first elements A21. So 1 by 2 elements of the matrix defined as 1 by 2 into modulus of minus 3i plus j. So here minus 3i means 3 into 2 plus j is 1. 1 by 2 into this minus 3 2s are 6, minus 6 plus 1, minus 6 plus 1, that gives 5. 5 2. Yeah, you have to take positive quantity. Last second row second elements 1 by 2 into modulus of minus 3 into 2 plus 2. And 1 by 2 into modulus of minus 6 plus 2 and gives minus 6 plus 2, it is minus 4. Again you have to take positive quantity, 4 by 2 means 2. Now required matrix becomes, required matrix is A is equal to, so first row first element is 1 and first row second element is 1 by 2, second row first element is 5 by 2, second row second element is 2. So this is all about construction of a matrix whose elements are given. When the elements are given, then their construction is done like this. Okay.